Okay, welcome to Properties of Quadratic Functions, Part 2. And what we're going to do is just look at some key features. I'm not even going to produce the graph here, but what I'm going to do is look at some key features of quadratic functions. And the first thing I'm going to look at is the intercepts. Those are pretty important points. So let's start off with the one that's fairly easy in this example, and we're going to try and find the y-intercept. Now, the y-intercept is where you cross on the y-axis. And what that means is the x-coordinate is 0, and we have to determine what the y-coordinate is. So that's really all there is to it. We're going to take our function here, and we're going to put a 0 in for the x. So it becomes pretty easy to work it out. You just go, well, y would equal 0 squared plus 2 times 0 minus 15. So I think I know what the y-intercept is. 0 plus 0 minus 15, so I think we're looking at minus 15. So this is the y-intercept. It is the point 0, negative 15. Okay, the next point that's important, or points, is the x-intercepts. And they're a little bit more involved, so I'm just going to give myself a little bit of room here. And what we have for x-intercepts is we have to consider, we don't know the x-coordinates, but we do know the y-coordinates. So x-intercepts, what's important here is, yeah, we don't know the x, but we do know that the y has to be 0. So I'm going to put in where the y is here in our function. I'm going to put the 0 there, and then try and solve what's left. So I got x squared plus 2x minus 15. And so we're going to really just go ahead and solve this quadratic equation. And the easy way to do that is to factor. Okay, at least in this example. So I'm going to have x times x. And then to get two numbers that multiply to make negative 15 and add up to positive 2, I think we're going to need positive 5 and minus 3. Okay, so now that I've got that, my solutions look to be negative 5 and positive 3. So keep in mind, here's what my x-intercepts actually look like. They are the points negative 5, 0, and the point 3, 0. Okay, so those are some pretty important characteristics about this graph. Now I have one more example of something else that you could be asked to do dealing with quadratic functions. Sometimes they give you some key points. So in this example, I'm going to tell you that the vertex is its location. I'm just going to give you where the vertex is. It's at negative 3 and 1. And I'm going to tell you there's one more point that's on the graph, and that's the point 0, 2. So from that, you should be able to draw a pretty good version of this graph. And what we're also going to do is see if we can identify any other points that are obvious on the grid. So I'm going to pull the grid up here. Let's hope it shows up. Ah, there it is. It's a little in my way, so what I'm going to do is move it. See if I can just slide it somewhere. Maybe just a little bit lower here. There we go. Okay. So that'll work. So now we're just going to pull the whole screen down a little bit and see what we can do. Okay, so hopefully you've written down the vertexes at negative 3, 1, and we've got the point 0, 2, because they're going to go off my screen here. That's okay, and I'm going to go ahead and plot them. So we've got negative 3, so 3 to the left, and 1, so right about here, that's our vertex. And then we have the point 0, 2 as another point on the graph. So from this, I can actually draw a pretty good version of the graph. If this is the vertex, it must mean it's roaring towards this guy and heading on up. Okay, something like that. Now, knowing that it's symmetrical, I could just analyze this relationship here from the vertex to this point and see another point would have to be 3 steps over and 1 step up. So 3 steps over and 1 step up. So this guy over here must be another point on my graph. And let's see if we can draw this reasonably accurately. Let's turn my hand this way and see what I can do. Okay. All right, so something like that. So anyway, another point on the graph, if you were asked to locate, this guy over here is at -6 and up 2. So we just did that based on the symmetry of the graph. And of course, a good picture really helps. And then knowing that, of course, that's the vertex. And that's where I'm going to stop with part 2.